Alrighty, let's do circles. For some reason, the SAT loves their circles, especially this formula right here, which is the center of circle equation. Okay, but let's see what kind of questions we can get for circles. One of them, multiple of them, is about the center of circle equation, which is this one. And a couple of them, if it is on the test, it's going to be finding arc length or angle is inside a circle. All right. So let's go ahead and jump straight into the center of circle equation. One thing that I basically see in every test, that's for sure. The below is the equivalent to the vertex form, and that's what we see the most. Okay. So why is it equivalent to the vertex form? I say it's because literally this equation is telling us what the center of circle is. And as you can see, just like the vertex form, we got negative sides right here. So we're going to see a similarity with the vertex form, at least the x value of the vertex form. So HK is the xy coordinates for the center, or is the radius. Notice how in the formula we got r squared. Okay, let's see some examples here. 1 through 4 are just center of circle formulas, and let's write down the center and the radius for all of them. So the center for the first one is 4, negative 5. Notice, since it's a negative, our center is going to be in the positive x, okay? And since it's a positive here, that's the value that's going to make this positive negative 5, because negative 5 plugged in here, y minus 5 is going to give us y plus 5. So that's why, just like the vertex form. So if you don't understand that, you can go back to the vertex form, but it's very simple to understand it. So let's do the radius. So the radius is going to be, actually the radius is squared, is 4. So the radius is going to be 2, because we take the square root of both sides. Okay. So the center is going to be at 4, negative 5, which is right here. And the radius is going to be 2 for each side. So it's going to be 2 up, 2 to the right, 2 down, and 2 to the left. Okay. And then we have a circle. So that's what the equation of a circle is trying to tell us. Let's do 2. So here we got that the center is negative 1, is always the opposite. So if you didn't realize it, it's always the opposite. Negative 1, 3, and the radius squared equals 25. Taking the square root of both sides gives us that the radius equals 5. All right, let's do 3. We got the center at 8, 9, and we got that the radius squared equals 1. So the radius, taking the square root of both sides, equals 1 as well, because the square root of 1 is 1. In here, we got the center at 0, negative 2. That's equal, that's just the center. And 50, let's see, radius squared equals 50. So the radius equals, taking the square root of both sides, the square root of 50. Can we simplify square root of 50? I think so. To simplify radicals, we always try to find the perfect square that's a factor of the number, especially dealing with square roots. Actually, when we're dealing with square roots, because if we're dealing with cube roots, we got to find the perfect cube that is a factor of the number. But let's just deal with square roots right now. So I know that a perfect square that is a factor of 50 is 25. So let's rewrite this as the square root of 25 times the square root of 2. Remembering the properties of radicals that we've learned before. Square root of 25 is 5. The square root of 2, it's just square root of 2. So that's why we're always looking for the perfect squares. Okay? Let's see here. Actually, let's do one little thingy right here. So let's see the transformation from number 1 to number 2. Let's draw number 2 really quickly. Just an extra kind of problem here. So at negative 1, 3 right here, the radius is 5. So 1, 2, 3, 4, 5. So it's going up to here. 1, 2, 3, 4, 5 up here. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So this will be the circle. So let's just talk about transformations. Okay, so we know that the circle from the red to the blue is going up from negative 5 to 3, so up 8, and left 5 pretty much, yeah, because it's from negative 1 to 4, so left 5. So understanding that we know, looking at the formula and understanding that we understand the formula, you got me. So knowing that we can analyze the formula and look at the negative signs here, so we know that 8 up is going to be the opposite. So we're going to be x minus 4. So the x-axis is 5 to the left. So we're going to do a plus 5 squared plus x plus 5, y plus 5. And since it's going 8 up, we got to do the negative sign here. Why? Because of the formula. It's also a negative on the y. It's different from the vertex form, because the vertex form, the y, doesn't have any signs attached to it. It's just a positive k. But in here is a negative k. So we got to understand that it's also going to be opposite. So this is going to tell us the new equation, x plus 1 squared plus y minus 3 squared. So it matches. So we're good. Let's do a problem from a previous test. A circle in the xy plane has its center at 3, 5 and has a radius of 6. What's an equation of the circle? So we know it's going to follow the pattern. X minus h squared plus y minus k squared equals r squared. So x minus 3 squared plus y minus 5 squared equals 36, which is 6 squared. So C is right. We could have looked at A and B, looked at the radius, and this is just radius, not radius is squared, so that's wrong. And this is a letter D has a positive 3 and a positive 5, and we know it's got to be negative based on the formula. All right. The question may ask us for the radius or the coordinate for the center. However, sometimes the equation will not be in the form above, which is the center of circle. So we must manipulate by completing the square to find the center or the radius. And here I'm just going to quickly touch on completing the square. If you already know it, you can skip it. Also, for those kind of problems, there is a calculator that you can use, so it's not as important for you to know. I still want to teach you completing the square. Why? Because it's a very good theory to know for the test in case you need to do it in some other question. So in completing the square, we're pretty much just trying to make from scratch perfect squares. And I'm going to show you how right now. So let's see an example of a perfect square. X minus 2 squared is a perfect square because that's equal to x minus 2 times x minus 2. And then when we distribute, we have x minus 2. X squared minus 2x minus 2x plus 4, which is x squared minus 4x plus 4. Okay, now that this matters, I just want you to understand that completing the square is pretty much making a perfect square out of nothing. And what we do is b over 2 squared, but this should be outside, not inside. So b over 2 squared. And b over 2 is the number that's going to be inside the perfect square when we create one. So as you can see, b over 2 squared, which is in this case negative 4 over 2 squared is 4. So negative 4 over 2 squared equals 4. So as you can see, this is a perfect square. And of course, we know that because the example was derived from a perfect square. So as we can see, b over 2, which is negative 4 over 2, is the number right here inside the perfect square. So let's make some perfect squares here. So let's do for this one, number 1. So what we do is we do, first of all, b over 2 squared. What's the value of b here? 8. So that's 8 over 2 squared. That's equal to 4 squared, and that's equal to 16. Alrighty. So we're gonna make the perfect square by adding 16 on both sides, because if we adding 16 on the left side, we gotta add 16 on the right side. So that makes this x squared plus 8x plus 16 equals 16. The 16 is gonna remain here. We're not gonna touch it. Okay. So x squared plus 8x. Actually, I can already complete the square here. So x plus 4, which is b over 2 here, squared equals 16. Okay, we just created a perfect square, so we're good. That's it. If we have a trinomial, what I advise you to do is always isolate the constant. So x squared plus 8x equals minus 4. So now we can complete the square. We know that b over 2 squared equals 16 because it's the same b value as the one above. So we do plus 16 here, plus 16 here. So that's going to be the only difference, the value on the right side of the equal sign. So that's going to be equal to x plus 4 because we know that b over 2 is 4 squared equals 12. So that's pretty much what completing the square is. So let's do here a previous question for the test. And this is a standard center of circle form. Okay, so as you can see, it doesn't follow the pattern x minus h squared plus y minus k squared equals or squared. It doesn't. So we gotta complete the square and make perfect squares. We gotta do that with the x and with the y. As you can see, we got the x squared minus 4x, and we got the y squared plus 6y. So the first thing I always do is put the constant in the other side of the equation. So x squared minus 4x plus y squared plus 6y equals 24. So let's complete the square for the x. So let's do that. So b over 2 squared for the x is negative 4 over 2 squared, which is negative 2 squared, which is 4. So we know we're going to add 4 here. If we add 4 to the left side, we got to do it on the right side. Otherwise, we're breaking the rules of math. So let's do b over 2 squared for the y. So that's 6 over 2 squared. So that's equal to 3 squared. That's equal to 9. Alrighty, so 9 here and 9 here. So now we can do the perfect squares. We just created 4 and 9 out of nothing. That's why we got to add them to the right side as well. And we're creating 4 and 9 out of nothing to make perfect squares. So we know that the perfect square is going to follow the pattern x minus, and that's going to be b over 2, which is minus 2, x minus 2 squared plus y plus 3 squared equals 24 plus 4 plus 9 equals 30. 37. Okay. So what's the radius of the circle? So we know that the radius is squared equals 37. Therefore, the radius equals the square root of 37. Okay, so from this, we would have known the center of circle as well, which is 2 comma -3. So that's the center and the radius as well. And again, we do have a calculator that can run a program and solve for this without you knowing how to complete the square. I'm just showing you how to do it in case you need to, all right? But we do have a program, and if you have classes with me, I will download these programs in your calculator, okay? So let's go ahead and do some find arc length or angle inside a circle. All right, so two things to know. The central angle has the same size as the arc length, and the angle that lies on any part of the circle has half the size of the central angle. So for example, this is the angle that lies on any part of the circle. So it has half the size of the central angle, therefore has half the size of the arc that's created. I always like to think of those like telescopes. So if the telescope is very far away, just like that, that's the first lens, that's the second lens. The first lens is always the smallest one, so I know it's going to be smaller, of course. Therefore, I can understand that's half the size. In the real life, technically, it's not half the size. It's just to be easier in your mind, okay? So 55. So this is going to be 110, for example. And if they were asking for the center angle, from here to here, it's also 110. And that's pretty much just what I explained up here. So arc AC has 110 degrees. That's pretty easy, to be honest.